Hi, we are doing chapter 3, chapter 1, section 2, measuring matter. Today, we are going to be reviewing what is the difference between weight and mass, what units are used to express the amount of space occupied by matter, and how is the density of a material determined. Okay, here's a riddle for you. Which weighs more, a pound of feathers or a pound of sand? If you answered a pound of sand, think again. Both weigh exactly the same, 1 pound. There are all sorts of ways to measure matter, and you use these measurements every day. Scientists rely on measurements as well. In fact, scientists work hard to make sure their measurements are as accurate as possible. So I've already talked about weight and mass, so this should be a review for you. Okay, suppose you want to measure your weight. To find the weight, you step on a scale like the one shown in figure 11. Your body weight presses down on the springs inside the scale. The more you weigh, the more the springs compress, causing the pointer on the scale to turn farther, giving a higher reading. However, your scale would not indicate the same weight if you took it to the moon and stepped on it. You weigh less on the moon, so the spring on the scale would not compress as much by your weight. All right. Your weight. Your weight is a measure of the force of gravity on you. So it is the force of gravity. Okay. All right. Let's see if I can. I don't know. I kind of wanted to get. Let's see. Just maybe go down like that. Okay. So it is the force of gravity on you. On Earth, all objects are attracted toward the center of the planet by the force of Earth's gravity. On another planet, the force of gravity on you may be more or less than it is on Earth. On the moon, you weigh only 1/6 of your weight on Earth. Mass. Why do you weigh less on the moon than on Earth? The force of gravity depends partially on the mass of the object. The mass of an object is a measurement of the amount of matter in the object. If you travel to the moon, the amount of matter in your body, your mass, does not change. But the mass of the moon is much less than the mass of Earth, so the moon exerts much less gravitational force on you. Unlike weight, mass does not change with location, even when the force of gravity on an object changes. For this reason, scientists prefer to measure matter by its mass rather than its weight. The mass of an object is a physical property. Okay? Units of mass. To measure the properties of matter, scientists use a system called the International System of Units. This system is abbreviated as SI, after the French name Système International. An SI unit of mass is the kilogram. So that's important to know. If we're measuring mass, it should be in kilograms. If you weigh 90 pounds on Earth, your mass is about 40 kilograms. Although you will see kilograms used in this textbook, usually you will see a smaller unit, the gram. Therefore, there are exactly 1,000 grams in a kilogram. So here's our equation of units of mass. Okay, a nickel has a mass of 5 grams, and a baseball has a mass of 150 grams. So what is the SI unit of mass? It is kilograms. Okay, so measuring mass. A triple beam balance measures mass. So this is what a triple beam balance looks like right here. Okay. How do you convert mass in kilograms to the equivalent mass, or its mass in grams to kilograms? So the average orange has a mass of 230 grams or 0.23 kilograms. So we use our conversion here, okay? A balloon and the air inside of it has a mass of 3 grams or 0.003 kilograms. A pineapple has a mass of about 1,600 grams or 1.6 kilograms. If this is difficult for you and you need help with this, if you can't do this kind of conversion, please let me know. Okay, send me an email. Volume. You have learned in section 1 that all matter has mass and takes up space. The amount of space the matter occupies is called its volume. It's easy to see that solids and liquids take up space, but gases have volume too. Watch a balloon as you blow into it. You're actually increasing the volume of gas in the balloon with your breath. So units of volume. Common units of volume include liter, milliliter, and cubic centimeter. Okay? Some plastic bottles hold 1 liter of liquid. Volumes smaller than a liter are usually given in milliliters. A milliliter is 1/1000th of a liter and is exactly the same volume as 1 cubic centimeter. Okay, that's important to know. Okay, when you're doing calculations, 1 cubic centimeter is the exact same thing as a milliliter, okay, in volume. A teaspoon of water has a volume of about 5 milliliters, and an ordinary can of soda contains 355 milliliters of liquid. In a laboratory, volumes of liquids are usually measured in a graduated cylinder. Okay, calculating volume. So we do this a lot in math class, especially when we're talking about solids of objects, are expressed in cubic centimeters. Suppose you want to know the volume of a rectangular object, such as the brick shown in figure 13. First, you would measure the brick's length, width, and height. Then you multiply these together. So we know from math, volume equals length times width times height. Okay, measurements always have units. So when you multiply the 3 measurements, you must multiply the units. So you can see here, we had centimeters times centimeters times centimeters equals centimeters cubed. How can you measure the volume of an irregular object, such as a piece of fruit or rock? One way is to submerge the object in water in a graduated cylinder. The water level will rise by an amount that is equal to the volume of the object in milliliters. Okay, density. Samples of 2 different materials may have the same volume, but they don't necessarily have the same mass. Remember the riddle about the sand and feathers. A kilogram of sand takes up much less space than a kilogram of feathers. The volume differs because sand and feathers have different densities. An important property of matter. Density relates to the mass of a material in a given volume. Often density expressed as the same number of grams in a cubic centimeter. For example, the density of water at room temperature is stated as 1 gram per cubic centimeter. This volume means that every gram of water has a volume of 1 centimeter cubed. Notice that the word per is replaced by the fraction bar in the units of density. The bar tells you that you can determine the density of a sample of matter by dividing its mass by its volume. So we've looked at this formula before. Density equals mass divided by volume. So calculating density. A small block of wood floats on water. Its mass is 200 grams and a volume of 250 centimeters cubed. What is the density? So go back up here. Our formula is density equals mass divided by volume. Okay, so the mass was 200 grams. Our volume is 250 centimeters cubed. And when you divide that, you get 8/10 or 8/100 grams per centimeter cubed as our answer. Okay, I did not, I can't remember if these are included in your homework or not. They may be. Okay, but we have done that before. So you should be able to, if you can't do that, send me an email. Okay. Sinking or floating. Suppose you have a solid block of wood and a solid block of iron. When you drop both blocks in a tub of water, you can see right away that the wood floats and the iron sinks. You know the density of water is 1 gram per centimeter cubed. Objects with densities greater than that of water will sink. Objects with lesser densities will float. So the density of this wood is less than 1 gram per centimeter cubed. The density of the iron is greater than 1 centimeter cubed. Watch a bottle of oil and vinegar salad dressing. After it's been shaken, you will see oil droplets rising above the vinegar. Finally, the oil forms a separate layer above the vinegar. What can you conclude? You are right if you said the oil is less dense than vinegar. That's why it floats on vinegar. Using density. Density is a physical property of a substance, so density can be used to identify any unknown substance. For example, suppose you were hiking in the mountains and found a shiny gold-colored rock. How would you know if the rock was really gold? Later at home, you could look at the density of gold at room temperature, then measure the mass and volume of the rock and find its density. If the two densities match, you would have quite a find. Okay? So this is the end of section 2. This is part of your homework. I will see you again tomorrow. Bye.